Welcome guys, thank you for joining. So today we are gonna see APB protocol. So thank you for joining. Thank you for your presence. So and then yeah. So today we are gonna see APB protocol. So APB stands for Advanced Peripheral Bus Protocol. So we'll see in this session it is a on-chip protocol. So first of all, you must know what is on-chip and off-chip. So on-chip means there is a protocol are working inside the chip, so it will perform this like a communication. It will do communication inside the chip only. It is called on-chip protocol. But off-chip protocol is nothing but they will they will work outside of the chip, so they will connect peripheral devices with the chip, like a microcontroller with sensor or a microcontroller with motors. So some kind of communication between the two peripherals, like a chip and peripherals. If we can use we must use the off-chip protocols like a UART or I2C, SPI kind of things. So on-chip means it will make communication inside the chip. Off-chip means it will make communication inside the outside the chip. I think I'm audible to you. So and then let's see in this session what is APB protocol. So these are the contents we are going to see in this session: introduction, terminology, AMBA block diagram, and then APB signal list, APB interface, and the APB state diagram, advantage and disadvantage of the APB. So mainly, basically, we can't use APB signal, so we can write and we can write the RTL code, and we can write the test bench code, so we can verify that. So we can't check with the hardware in the on-chip protocol. But if you are doing a off-chip means you can check with the hardware. So we can use a hardware to check the your functionalities and your SPI and your I2C. So we can check the functionalities in the hardware, but we can't use APB protocol in hardware. So and then we'll move to see the APB. So firstly, introduction. So the APB is a protocol, so it comes under the AMBA protocols. So AMBA, so Advanced Microcontroller Bus Architecture. So this is a stands for AMBA. It's like an ARM company. So ARM company is standardized some protocols like APB, ASP, AHP, and AXI. So it's these protocols, they are standardized, and then and then year by year they are increasing the features of protocols. They are increasing the speed and the performance and the frequency of the protocols. So protocols like AXI, APB, HB. So it's like a standardized communication for designing the high performance embedded microcontrollers. So these are the three main protocols: AHP, APB, ASP. AHP stands for Advanced High Performance Bus. ASP stands for Advanced System Bus. So and then APB stands for Advanced Peripheral Bus. So and then another one is AXI, Advanced Extensible Interface. So these are the protocols given by AMBA. So let's see what are the protocols like APB, HP. So AHP, so Advanced High Performance Bus. So advanced high performance, it is like name itself, it having high performance. So it will use high clock frequency. So it will perform speedily compared to APB. So that's why it's called high speed protocol, advanced high performance HP bus. So on the AHP act as a high performance system backbone, like a backbone bus. So it is like a backbone bus. So it will this AHP protocol only connecting the APB and the AXI kind of thing. So we'll see in this session. So AHB supports a efficient connection of processor, on-chip memories and off-chip external memories, interface with the low power peripherals. So coming to the APB, Advanced Peripheral Bus. So APB is a low power peripheral. So AMBA APB is optimized for minimal power consumption and reduced interface complexity to support the peripheral function. So it means it will use only less it will use only less power. Why? Because of it is low power consumption, and also it is a low frequency, low bandwidth. So it is like a very low speed. So it consume only low power. So and then reducer interface complexity. So we can write the code easily. Why? Because of there is no lot of signals, there is no complexity while connecting the signals. So there is less signals compared to other protocols. So we can reduce the complexity of the protocol. And then APB can use it in a connection with either version of system bus. So we can make connection between the ASP. So and then we'll move to the terminologies. So there are three terminology in the protocols, like a bus cycle, bus transfer, and then burst operation. So bus cycle is a one clock period of the clock. So we can, so the bus cycle is a basic unit of one bus, one clock period. And for the purpose of AHP or APB protocol description, we defined for rising edge to, so we know that, so one cycle is a rising edge to another rising edge. ASB, so AHB, APP are work based on the rising edge to rising edge. It's like a passage to passage, but ASP bus based on the falling edge to falling edge. So this is a difference between the bus cycle of the protocols. AHB, APP protocol are use the passage to passage clock cycle, but if you take an ASP, it will perform under the falling edge to falling edge cycle. So and then bus transfer. So and then bus transfer. So how it can bus transfer? So in AMBA, ASP, AHP bus transfer read and, so if you take an AHP and ASP, it will do read and write operation with one clock cycle only. So it will take one or more than one. It means it take one at most one, and then it will take up to one or more bus cycle to make the bit transfer of read and write operation. But if you take an APB, it will take at least two cycles. So it requires two bus cycles, like two cycles to do the read and write operation in protocol. So ASP, AHP will only need one cycle, but APP need the two cycle to transmit and receive some data between the master and the slave. So whole like APP, AHP, XI, all things based on the master and the slave. Like if you take an UART, there is a transmitter receiver. Same like in the protocols, we are using master and slave terminologies. So and then let's see the burst operation. So burst operation is defined one or more data transmission initiated by master. So you can see here. So if you want to transmit data from master to slave, so master only will initiate. Master only will start the communication. So this is a burst operation which are constraints with transaction to an increment region for address space. So you can see here no burst operation is supported on the APP. So AXI, AHP are using the burst transfer, but there is no burst transfer in APP. We can send by the byte by byte, like a byte by 8 bit of data or else 10 bit of data spaced on our APP signal. So let's see the AMBA block diagram. So this is AMBA block diagram. Here you can see here there is one bridge. So you can see here AHB is high speed bus, so it will make communication very fastly compared to APP. So that's why that APP protocol are using for connecting the high performance ARM processor with the DMA master, or high bandwidth external memory interface, or high bandwidth on chip RAM. So for this all components blocks must it will requires more speed, like a high speed communication, high speed data transferring. So that they are using the AHP protocol. And you can see also here UART and the keyboard timer, these all peripherals are connected with APP protocol. And so if I this is my ARM processor, so I want to perform the UART. I want to perform UART and the keyboard, so keyboard or timer. So I want to do some action in UART. So how it will work means, so it will be, so ARM processor and bridge, it will make so it will do communication at the high speed. And so but APP is a low speed, like a low frequency, low bandwidth. So how we can't make communication directly for AHP to APP. So if you want to so and then this bus like AHU bus based on works at the high speed, but APB bus work at the low speed. So we can't make communication directly. For that we are using bridge. So and then there is no, if I'm using the both all the bus like APB means my system will work slowly. So if I'm using the low speed protocol, so the data transmission also very low, so I can't do efficient transmission in the in the while processing the system. So for that we have to convert the low speed to high speed, high speed to low speed communication buses. So for that I'm using the bridge here, AHP to APB bridge, ASP to APB bridge. So it is used for converting the high speed to make the communication between the high speed, and then high speed is HB and the low speed is APB. So it will act as so we have to use bridge here. If you take in this part, so bridge is, so we know that every AMBA signals, AMBA protocols, it having the master and the slave. Same like if you take in this part, so bridge is act as a master and then APB is act as a slave. So APB variable like if you take an UART is act as a slave. So this is bridge. This bridge is act as a master, and then this UART act as a slave like APB master, APB slave. Here for this here if you take an ARM processor and a bridge, this bridge act as a slave, is AHP slave, and then this ARM processor it is act as a AHP master. So this is AHP master, this is AHP slave. If you take in here a bridge is a APP master, UART is APP slave. So this is how on the chip they are communicating with these protocols, AMBA protocols. So these are the advantage and the application of AMBA protocols. High performance pipeline operation, AHP. So multiple bus transfer, bus master, so bus transfer, split transaction in AHP. So we can do in AHP like a high performance pipeline operation, multiple bus master, but you can do only the APB is it having application like a low power, simple interface, and suitable for many peripherals. So these are the application for protocols. So and then we'll see the main thing, APB signal list. So these are the APB signals like P clock. So here P is refers to APB. So if you take an AHB, it will start from H. So H is refers to AHB signal. So if P is refers to APB means this particular signal will come from APB protocol. So for that indication purpose we are using this P in front of the signal name. So this is why, because of here inside the bridge, so here inside the bridge it having the AHB signal and the APB signals. So if I am while writing the code, I will may confused how to connect the signals from APB to AHB. So there is some misunderstanding or collision will happen in bridge. So there is a chance to misconnecting from the signal. For that I'm using like a indication like a P is indicated for APB and then AHP as for H. So kind of thing. See, AXA means A. So and then this is a P clock. So this is a P clock for my APB protocol. So it is input clock. So and then P reset N. So N is refers to active low reset. So APB protocol will reset in the active low reset condition. So and then address. So it having the 32-bit address with. So in the APB we can store, we can save, we can access the 32-bit of address. And then P cell X. So P cell is a slave select. So we can use multiple master and multiple slave. So multiple slave means we having the n number of like a one. If you having the 5 slave means, so if you want to connect the 5th slave means you just have to queue here P cell 5. It means I'm connected to my master is have to connect to fifth slave. For that, here instead of x we can give some value for the slave indication, p cell, so it's like a p slave selection. So and then p enable. So p enable is like a signal. So by if the rising edge of p enable occurs in the middle of the so you can see here the enable signal is used to indicate the second cycle of an APB transfer. So second cycle, so it means it is used for to indicate the second cycle of the APB transfer, and then rising edge of the P enable occurs in the middle of the APB transfer. So and then P write. So P if the P write is low means I can send data to slave, or if P write is low sorry P write is high means I can send it to slave. If it is low means I can't I can read. So and then PR data. So it is my output signal of APB protocol. It will read 32-bit data from the slave. So master will read the 32. So master will get the data from slave. So say like a P 32-bit, 32-bit of data. When means if the P rate is low means I can get the data from slave. So like a, if you are imagine you are the master, you are receiving some input, but it is the output for slave. So that the signal is PR data. So PR data is input for master but output for slave. So this mean output signal PR data, P read data. So and then P write data. So it's like a P writing. So write data bus driven by a peripheral bus bridge unit during the write cycle. So when P write is high, write data can be up to 32-bit wide. So the write data also 32-bit wide. So these are the signals in the PPB. So this is a bridge interface. You can see here it's like act as a master. APB bridge act as a master. So slave one, slave just like a cell means slave selection. So and then P enable, P address, write or write data. So if it is for particular address, if my write is high means I can write into data. So I can write into memory. And then what is that particular data, P write data. So and then my inputs of P active role is set, and then P clock. So and then system bus slave interface. So and then PR data it is received from the slave. So I will show you upcoming slide. So this you can see here this is a slave. So my inputs of slave is a P cell, P enable, PR data, write, P reset and a clock, and then it's a synchronization protocol. It's like a synchronized serial protocol. So and then it will use the same clock cycle. For that I'm saying this is synchronous protocol. So and then PR data, PW data, write data, and then PR data is the output of my slave. So it will act as a input of my master. So and then this is the whole communication. So this is the whole master and slave communication. APB master, APB slave. So these are input for the APB bridge. So these are the communication signals: P cell, P enable, P address, P write, PW data, ready, slave error. So P ready. So P ready is indication of I'm the slave. I'm telling to master I'm ready to send the data, PR data to master. So I'm just saying to master I'm ready to send the data to you. So and then PSLVERR, it means P slave error. So P slave error is why I'm using means if anything happens like if there is the so both are so I'm just writing into memories. It's like it's like a APP slave have it's like a memory. Imagine it's like a memory. APP slave is one memory. So I'm just writing into memory. For the on the time I will may receive some error or data loss. If it is happens means I'm saying so there is a error in your data writing. So please do again. So this is a place P slave error signal. So it's while writing in the memory while using the APP slave. If there is happens like wrongly, so errorly, it is by using this signal I can indicate to I can give the information to master. So this is the usage of p slave error. So if any unknown value or unknown values are occurred, or high impedance value occurred, or if a right address and the right data are mismatched, so and then so if the master will will master right address is different, and then right data is different, so it will change some right operation. So if anything happens wrongly, I can indicate by using this piece slave error. So this is an important thing, state diagram. So based on this state diagram only, we are gonna write the RTL code for that. So this is firstly it having the three states: ideal state, setup state. Sorry. So ideal state, setup state, and then access state. So you can see here that it's like a FSM only. So it's like a overlapping FSM. So it's like FSM only. So and then you can see here ideal, setup, access. This is my three state. So so I'm just saying some conditions. So if there is no transaction, means you must stay in this same state. If any transaction happens, means it's like you can move for setup state. So in the ideal state, you must have the p slave x 0 and then p enable is 0. So then when in the ideal state, this is the logic for ideal state. So in then setup state, p cell x 1, p enable 0. It means, so I just selected the master is selected the signal, and then that master want to connect with particular slave. You can see here p cell x1 equal to 1 means it's like a slave selection. If the master selected the slave correctly, so we can particular master, it can move to access state. But here you can see here p enable is low. So if both are 1, so if I just master selected the correct slave and then enable is high, so it means I can send and receive data from master, so from the master and the slave. So this is the state. So state setup, access, and then this is a condition. If a p cell equal to 1 means it is stay in this stay in the setup state. If p cell and p enable are both are 1 means it can stay in the access state. So and then if ready is 0, it will stay in the same state, or if ready is 1 means it will move to setup state. Why it will move to why it will move to setup state if ready is 1? Why means p ready is like output signal of the slave. So why that particular signal will do it will saying to master, I am ready, I can give data from slave to master. So it's like a data read only, so it's like a data reading operation. So I can read I can give the data, and then I can go with the next data, so I can go with the next byte. So for that reason it will move to the setup state if the only period is high. If period is 0 means it will stay in the same state, and then it will move to the p ready, so setup state. If any transfer happens, means if there is no transfer in the list, means it will move to the idle state. So this is the APB state diagram. So this is a read transfer. So you can see here p write is low, so it will take up to 2 clock cycles to read the data. P write is low, and then p address is address 1. So in the second cycle only I am getting the p data. So and then p enable will arise at the, you can see here this is a 2 clock cycle. This is one passage, this is one passage. It will take 2 clock cycle to make the one transaction. So and then PR data. So you can see the PR data. So I am getting data at the second clock cycle only. So we can see here P enable also high at the second clock cycle. So I just do P cell is high. So it means I just selected my slave. So and then I can get the PR data right, and whatever I'm writing into data, I'm getting the second cycle. So and also P enable also must be high in the second cycle only. We'll see in the signal, we already seen in the signal list. So and then this is a wave diagram for my rate transfer. This is a write transfer. So write transfer means, so P enable is enable in second cycle, and then P write data is that particular data and then particular address. You can see a P write is high. It means I'm writing. So slave is selected. So it will take 2 cycles to make one transaction like a write or read operations. So this is the APB protocol waveforms. So these are the advantage like a low power, simple interface, suitable for many peripherals. So and then this is the disadvantage of the APB protocol, single master scalability. So and then if you guys are really interested in this master class, you can convert this master class into 1 month internship. So internship on FEJ. So you will get all the details recording session, all the details presentation, exclusive project code, and then VIP community group for doubt clearing, and the internship updates, and you will get the internship confirmation letter from IET, and then you will get the 90 days LMS course access, and you will get the assignment and task, weekly live sessions, and we are providing also some resume building ideas, mock test. So internship certificate you will get at the end of the session. So and then participation certificate. So you will get all these benefits at the discounted fee of just 999. So our registration link is, so this is my registration link. By using this link you can join our internship program, and also you can find in our chat box, live chat box. So we can find the link in chat box. And also this is the our regular fee 3999. So in this masterclass period we are providing at the discounted fee of just 999. So and then this is a limited time period offer, it will close today only. So we'll see the coding part of APB. So this is the this is a top modules like a RTL code for APB master. So like I just defined here some value like ideal. It's like a parameter only, tick define, ideal 0, setup 1, access 2. So and then this is my signals. Yeah, you can notice here P clock, so it means APB clock, P reset, active low reset, P cell 1. So I'm just choosing my slave 1, P write, P enable, and then P address, P write data. So it means both are 32-bit wide. So and then PR data, so 32-bit wide, P ready, P slave error. So these are my input output signals we already seen in our PPT. So and then we'll see the internal signals. So state and the next state. It's why am I using I'm using the two internal signal like a state and next state. Why means I want to change the state from one state to another state. For that I'm just registering my states. So and then delay. So and then is a memory. So it's like I'm writing into, it's like a slave memory. So 32-bit, I can store each memory location at the 32-bit of data. So depth equal to 5, it means 2 power 5. So 2 power 5 how means 32, I think 32, 2 power 5 32 minus 1. So it means 32 memory location, 31 down to 0. It's like a 32 memory location. Each and every memory location I can store the 32-bit of data. So initially it will stay in the ideal state initially. So and coming to the always block. So passage of P clock, passage of or neckage of reset. So if I'm using this means it's active low reset. So and then so in the reset condition I'm just saying we have to stay in the ideal state. So my current state will be ideal, and then I'm writing the what you can see here mem of I. It means for each means that it will count from 0 to 31. So at the memory location of 0 to 31 I'm just writing some F means like a full value, all are having 1 1 1. Or else if it is not in the state condition, it will move to the next state. So and then you can see here, if any change happen in state, and P cell and P enable, it will execute this always flag. If state changes ideal means this is my ideal conditions. Delay, I'm giving some random delay, and then slave error 0, P ready as 0, and then P data. So I'm just assuming some 0 value for R in the idle state. So I will receive this value. I will receive this value in my idle state. So I'm just assigning that only. If the P cell is 1 means you can move for setup state. You can see here, if the slave P cell is 1 high means you can move for setup state, or else you have to stay in the same state. And then in the setup state, so P ready is 0, P slave error is 0. If there is no error, and then P ready also 0 means it will check, and then P enable, if the P enable is high means, and also you can see here, repeat the deposit of clock. So at particular delay, I'm just giving the P ready is equal to 1, and then if P address is more than or equal to depth means I'm saying one error message like a dollar error is like a memory address more than limit. It means, so if my address is more than, if my 32-bit address is more than my memory depth, if it is happens means I'm saying memory address is more than the limit. So this is the error message. Else if I'm checking another condition, so P write is high, so I can P write is high, and then write data, it's like a 32-bit X or 32-bit of Z means I can say that invalid data in PW data. It means if my P write data is 32-bit X or 32-bit of Z, I'm checking that only. If it is having unknown value or high impedance value, I'm saying that particular data is not, it's invalid. So this is error message. So you can see here, and the particular time I'm just printing P slave error equal to 1. So I'm indicating, so there is error in the slave, so it's like a P slave error. So and then if the P write is 1 means, so you can see here, if P write is 0, it means low. So I'm using not, I say large bit bitwise not, so logical not here, this is logic not symbol. If it is a P write is 1, it's like a 1. So if it is 0 means I can write into, I can't write, I can read from the memory. So you can see here, I'm just reading from memory. So mem of address, so that particular address depth -1. So from the I'm just assigning to my PR data. So PR data is my it's my output of P slave, so like a slave output. So and then we'll move to this memory. So if it is having, so if a mem of P address depth, if it is having 32-bit of F means it just displaying that address content having some, it is just displaying whatever it having the values in the display window. And then and that time it means it having the 32-bit of F means all are high, so this is error only. So that I am just giving some P slave error equal to 1 to indicate the reading data from return address. So and then I'm going to next state is access state. So in this access state is P ready is 0, and then if write data, so if write is high and P slave error, and if it is no error and then write is high means I'm gonna write into memory like a PW data. You can see I'm just writing into memory. So what PW data having the input value, I'm just writing into particular memory with address, P address with locations. So depth is a 5, so 5 4 down to 0. So I'm just assigning to my memory. I'm just writing into memory. So and then if p cell is if there is no p cell high means you must stay in this idle state, or else if you have to go for next state, so in the access state. Some I shown, yeah, I shown here like if a p cell is 1, and then if there is no transfer means you have to move for idle state. If there is a transfer means you have to move for setup state. So that's why it's doing. So this is a APB code, simple only. So you can write more complex. So you can write the more logic in APB. So we can declare more secure logic. So it is a simple logic only. I am checking the slave error p ready. So there is additional signal in the APB. So you can refer the spec on your Google. So it is open source only. AMBA protocols. So you can try at your home. So writing this, you can write the test bench code for this. So